Hello YouTube. I'm sure you're all familiar with SETI, the search for extraterrestrial intelligence. Active SETI is a branch of SETI that attempts to contact extraterrestrials directly by sending messages to possible abodes of life elsewhere in the universe. It's sometimes also called METI, for messaging extraterrestrial intelligence. A number of authors have argued that we should refrain from active SETI because it poses potentially catastrophic risks. Listening for extraterrestrial messages is fine, but actively sending messages ourselves should be avoided. We don't know the character or the capabilities of the beings that we're attempting to contact. David Brin likens those who pursue active SETI to ignorant children screaming hello at the top of their lungs in the middle of a dark, unknown jungle. So is this reasonable? Should we refrain from sending messages to space? Well, the first question is, if some extraterrestrial civilization picked up our messages, what risks could they pose? The obvious one is that there may be some potential for some kind of invasion. Perhaps the aliens would view us as mere commodities. A highly advanced civilization might look upon humans as we look upon cows and pigs. After all, we do have a rich record of the consequences of contact between different human cultures, and the stories are often pretty unpleasant. I won't go into that history here, but just look up colonialism and genocide and so on, and you'll see that contact between human cultures is often quite bad. But second, even benign extraterrestrials might pose a threat through pathogens. Perhaps some kind of extraterrestrial virus could exterminate Earth life, much as disease spread by European colonists stormed through the native inhabitants of the Americas. Now, the potential for infection is usually countered by noting that on Earth, pathogens only infect close species. They rarely jump large gaps. A virus that infects pigs might transfer to humans, but it's very unlikely that a virus that infects bacteria would do so. Of course, on the other hand, it's not clear that we are entitled to make an induction from life as we know it. Extraterrestrial life would have had a wholly different evolutionary history, so maybe it's a bit rash to assume that extraterrestrial pathogens would operate in the same way as terrestrial ones. Nevertheless, in this video I'm going to focus on the possibility of invasion. Now, this risk assumes that extraterrestrials could make direct contact with us, and that would require interstellar travel over hundreds or thousands of light years. Is that feasible? Obviously, it's beyond current technology, but in principle there are a number of possibilities. If you look up interstellar travel online, you can read all about them. There have been some very speculative proposals for faster than light travel, but it seems pretty likely, given our current knowledge, that the speed of light is the limit, in which case there's obviously no risk of physical contact with extraterrestrials in the immediate future. But certainly a nearby civilization may well be able to contact our ancestors, and assuming that we have duties to the future inhabitants of our planet, we have to consider the potential risks of that contact. Now, an assumption that's made in much of the literature on the risks of active SETI is that any civilization that receives our transmissions is likely to be far more sophisticated and far stronger than we are. So if we were to establish contact with such a civilization, they would have the ability to reach our planet if they so desired. I'm going to call this proposition S. And it's easy to see the allure of this proposition. Human technology is still very young. The Industrial Revolution occurred less than 200 years ago, and we've been capable of sending and receiving interstellar transmissions for merely 100 years. Technology develops extremely rapidly relative to cosmic and evolutionary timescales. Given that we have developed over only a century or so, it's extremely unlikely that we would contact an extraterrestrial civilization at the same stage as us, or at an earlier stage than us. The Milky Way is 10 billion years old. We've been a communicating civilization for only 100 years. So we're only at the very beginning. Success at active SETI would likely put us in contact with a vastly superior species. Now, assuming that contact is established, the probability that an advanced civilization contacted by us would invade us, probability of D, equals the probability of S, so that's the probability that that they are vastly more technologically sophisticated than us, multiplied by the probability that they are malicious, probability of M. And this argument suggests that we know that the probability of S is high, so for contact to be safe we would need to assign a low value to the probability of M. But there seems to be no justification for that. So contacting extraterrestrials may well be very dangerous. Applying a basic precautionary principle, we should refrain from contact. So that the thought is the probability of danger to the human species depends on two factors: the capabilities of the extraterrestrials and the character of the extraterrestrials. We have good reason to think that extraterrestrials would be capable of harming us if they so desired, and so we're sort of banking on them not wanting to harm us. But what possible justification could there be for that? So let's consider the probability of M, the probability that extraterrestrials might desire to harm us. Well, the optimistic view is that advanced civilizations would no longer be aggressive, they would be more morally developed. Carl Sagan once suggested that aggressive societies would not survive. Either they would destroy themselves through nuclear warfare or something similar, or they would become peaceful. With greater technological capacities, civilizations have a greater ability to destroy themselves. So any society that we contact would have to have quite strong moral values. They would have to be benign. Life forms that are not benign simply would not inhabit the cosmos. They would generally destroy themselves very quickly. Only the benign civilizations would survive. So the vast majority of civilizations we can expect would be peaceful. Similarly, Peter Singer has written of what he calls the expanding circle of moral concern. Initially, humans were concerned only with the immediate tribe. Anybody outside the tribe simply didn't matter morally. Your moral obligations applied only to those few people that you saw on a daily basis, only to your family and the other people of your tribe. Over time, our circle of concern has expanded. So as societies started to organise themselves into nations, people saw themselves as members of wider nations, and the circle of concern expanded to people they may never even meet, people across the whole country. More recently, the circle has expanded to include the whole of humanity, all different races, classes, sexes. We adopt a kind of egalitarianism. We assume that all people have certain basic rights and are equally deserving of moral treatment. Hence, we have human rights laws. And now with the development of animal rights, objections to the use of animals in medical testing and farming and so on, we can see this circle of moral concern expanding to other species. So there's a kind of moral progression. We're becoming increasingly altruistic, increasingly empathetic, and the final step would be the extension of moral concern to all other civilizations in the universe. And the thought is that we can expect that extraterrestrials would exhibit similar moral progress. Part of the expansion of this circle of moral concern hinges partially on the development of empirical knowledge. We have learned that other people are like us. We've learned that our tribe is not fundamentally different from other tribes, that our race is not fundamentally different from other races. And more recently, we're learning more about the mental capacities of non-human animals. We know that they have the ability to suffer and experience emotions just as we do. It was once thought that animals were merely automata that exhibited simple stimulus and response reactions and were incapable of feeling genuine pain and genuine emotion. Our more sophisticated view of animal minds has made it a lot more difficult to justify inhumane treatment of animals. And we can similarly expect that as an extraterrestrial civilization learns more about the world, they will come to see that what matters is the mental capacity, not tribe or race or species. What might we say about this argument? Well, the first question is, has there in fact been an expanding circle? Perhaps this fits Western society, but we might consider that tribes with animistic religions, for instance, already extended moral concern to large parts of the environment beyond humans. Also, religions like Buddhism and Jainism preach respect for all life and try to avoid killing any sentient creatures. So it's not obvious that all societies actually exhibit this same kind of pattern, in which case we shouldn't expect extraterrestrial societies to exhibit that pattern. But more importantly, even if all human societies do exhibit this pattern, notice that applying this to extraterrestrials is an induction from one species. But just because the human species develops this way, why should other species? Perhaps there is something special about humans that makes us particularly empathetic, that makes us unusually likely to extend the circle of moral concern beyond ourselves. And, given the behaviour of humans, to discover that we're an unusually kind and empathetic species would probably be a rather depressing conclusion. But I don't think it would be a very surprising conclusion. I mean, imagine if, for example, domestic cats had evolved into a highly intelligent species. Cats are not nearly as social as our ancestors were, the primates. They may well be far less inclined to extend the circle of moral concern. Our ancestry suggests that we are unusually pro-social, and so perhaps we are unusually empathetic. And notice that from an evolutionary point of view, to extend moral concern to other races, people in other countries, to other species and so on, is a kind of misfiring of our reactions. Concern for close family members is a product of kin selection. There's strong selection for being, for sort of having moral concern for other family members because they share your genes. So there's selection for that. Similarly, there's selection for reciprocal altruism among people of the same tribe, people that you see a lot on a daily basis. But being concerned about other species or about other humans in faraway countries is not adaptive. It's a complete waste of time and resources from an evolutionary point of view. Perhaps extraterrestrials are better adapted, and so their moral responses don't misfire as ours do. They wouldn't waste their resources caring for other species. Now, the defender of active SETI might suggest that in order to build an advanced civilization, you need cooperation, and that was, of course, Carl Sagan's point. But of course, a degree of brutality can also achieve some pretty striking results. Slavery was quite useful for the people who weren't slaves. It's at least plausible that a species much less empathetic than ours, where it treats other people outside its tribe as mere commodities, could achieve quite substantial progress. Cooperation is required in some degree to have an advanced civilization, but that kind of cooperation wouldn't necessarily lead to extending empathy to other people, as far as I can tell. Another question is, what causes the expanding circle in humans? We need to know something about this in order to evaluate how likely it is to be replicated among extraterrestrials. But quite a simple hypothesis here is that one necessary feature of a civilization extending the circle of moral concern is easy access to resources. It's easy to care for a member of another tribe or for another species when you're not starving. When push comes to shove, we look out for our own. In a house fire, who would you save? A dog or your close friend? Your close friend or your brother? You generally go for whoever's closer to you. So we can't necessarily assume the conditions of an extraterrestrial society. Perhaps they're desperate, perhaps their star is dying, or they've run out of resources. They might be highly morally advanced, but in a desperate situation, being morally advanced doesn't really count for much. So I'm not really convinced that we can assume that extraterrestrials wouldn't desire to harm us. Now let's turn to S, the claim that the probability of S is high, that it's very likely that any civilization we contact would be far more advanced than us. This is based on the fact that the civilization is likely to be far older than us. They're likely to have been a communicating civilization for a far longer period of time. And the assumption is that in general, the older a civilization, the more advanced it will be. A civilization millions or billions of years older than us will be that much more advanced. Should we make the assumption that a civilization far older than us would also be far more technologically advanced? One objection here, raised, for example, by Nicholas Rescher, is that it's not really legitimate to compare civilizations of different planets on a scale of more or less advanced. Rescher says that to say that some society is more advanced than us implies that they are in some sense doing the same thing as us, or pursuing the same goals as us. And we have no grounds for thinking that this is the case for extraterrestrials. Consider a house that has very sturdy foundations, good insulation to retain heat, it has roofing that keeps out the rain, it's fitted with all the modern utilities, it has a lot of space, it has really nice art on the walls, it's been checked out by health and safety inspectors and so on. Now consider another house that is a ruin. The windows are smashed in, the floorboards are rickety, the walls are crumbling and the roof is leaking. Which house is the most advanced? Well, we'd probably prefer to live in the first house. But suppose that the latter house has been built specifically as part of a movie set. Maybe it's some old haunted house for a horror movie. Well, it's not clear that we can really say which house is better overall. The creators of both houses had very different goals, and both houses meet those goals very well. In the same way, Rescher suggests that judgments of how advanced a civilization is technologically just might not make much sense, because the extraterrestrials might be pursuing completely different goals to us. I think that this goes a bit too far. Technology, broadly speaking, is concerned with manipulating nature, and in this very abstract sense of the goal of technology might provide a general way to measure technological advancement. After all, note that different humans often have very different goals with the technology that they create, but we can still measure technological advancement of different human societies. But in any case, we can relativize the question of advancement to specific capabilities. In fact, we can just get rid of talk of advancement altogether and simply say, for instance, that society X has the capability for interstellar travel, say, whereas society Y does not. Society X has the capability to destroy society Y, but not vice versa, and so on. So from that point of view, S is the claim that since any civilization we contact will have been developing technology for a vast amount of time, they're very likely to have developed capabilities that could pose threats to the Earth. That's a perfectly coherent claim, I think. So it's coherent, but is it true? Well, another objection to S is that S rests on extrapolating present technological development into the future, and then assuming that this pattern of development would be found in all other civilizations. On Earth, we've seen that technology has progressed quite rapidly over the past few hundred years, and we're assuming that that's going to continue. Now, an important point to note is that so far science has grown in an exponential manner. This is demonstrated by Ludwig Farbach in his article How the Growth of Science Ends Theory Change. Farbach quantifies the amount of scientific work done in two ways. First, by the number of scientific papers published per year, and second, by the number of working scientists in any year. And he finds that over the past 300 years, the number of scientific papers published per year has doubled every 10 to 15 years, and the number of scientists has doubled every 20 years. So assuming that number of published articles and number of working scientists gives us at least a rough measure of the amount of scientific work that has been done, it follows that about half of all scientific work ever done was done in the last 15 to 20 years. About 80% of all scientific work ever done has been done since 1950. We find a similar thing with costs of research. The discovery of the first antibiotic, penicillin, was mostly serendipitous, and the cost of the research that led to that discovery was relatively low. The cost of discovering new antibiotics is so expensive that many pharmaceutical companies just don't even bother anymore. They focus on other investments, and that's one reason why we have trouble with antimicrobial resistance. No new antibiotics are being produced. It's just too difficult, too expensive. In general, one pattern that we find in the history of science is that science takes up more people, more effort, more time, more money as it develops. In the past, science was pursued by eccentric gentlemen amateurs. Single individuals could make an enormous impact on entire fields. Think about the impact of Darwin on biology or Newton on physics. Newton completely revolutionized physics. It was just one man. And that was something he did in his spare time. He actually spent most of his time working on alchemy and other occult studies. Modern science, on the other hand, is generally in the form of what's called big science. Science is organised into large-scale, expensive projects that involve big research teams using high-tech equipment like particle accelerators. So in many respects, there's been an exponential increase in the amount of scientific work and perhaps also in the scale and cost of scientific work. Now, the problem is that this exponential increase of scientific work has arguably not been matched by an exponential increase of scientific development. Rather, the exponential increase in the amount of scientific work has been required to maintain a linear rate of scientific development. Of course, quantifying scientific development is not an easy matter, but two proxies we might take are, first of all, the number of revolutions in a science, and the other, the impact of science on certain aspects of our lives. So with respect to the former, the kind of rate of scientific revolutions, consider the development of physics. I take it that some of the big developments in physics are the Newtonian revolution of the 17th and 18th centuries, the unification of electricity and magnetism in the 19th century, general relativity and quantum theory in the early 20th century, maybe thermodynamics, some of the developments there in the 19th century, and maybe the development of the Standard Model in the latter half of the 20th century. Now, as we noted, the vast majority of scientific work has been done since the mid-20th century, but there seem to have been fewer big developments. A lot of the big revolutions in physics occurred hundreds of years ago. So perhaps string theory would count as a recent revolution, but even that remains rather controversial. There are some very strong criticisms of string theory from physicists like Lee Smolin and Peter White. Probably the most substantial concern about string theory is that it still hasn't built up the kind of striking empirical evidence that the other paradigms of physics display. And the main reason for that is just that today in physics we're hitting experimental limits. I think I recall reading somewhere that in order to test some of the central claims of string theory, we'd need particle accelerators the size of the Milky Way galaxy. So it's just beyond our ability to test some of these claims. So in some respects, the rate of scientific development may actually be slowing down. What about the application of science to our lives? Well, consider life expectancies. This chart shows the increase of life expectancy over, I think this is in the US, over the last century. Despite the increase, the exponential increase in the amount of scientific work, increase in life expectancy is linear, and you'll find the same pattern in all other countries. And note that this increase might not continue much longer. Today we face severe problems even maintaining current life expectancies as they are, never mind increasing them. The proliferation of antimicrobial resistance will reduce life expectancy substantially if we can't solve it. And there are certainly plausible suggestions for solving antimicrobial resistance, things like phage therapy, but nobody really knows at this point whether phage therapy will work as effectively as antibiotics. And even if it does, notice that solving antimicrobial resistance, and so maintaining the benefits that antibiotics brought us, has already burned immeasurably more money, time and effort than the discovery of antibiotics in the first place. Now, the basic sort of point here is that initial scientific advances pick the low-hanging fruit, as it were. You solve the easy problems first, and so it gets increasingly difficult over time to keep solving problems at the same sort of rate. We need an exponential increase in scientific work to deliver a linear increase in scientific development. And of course, there are very good reasons to think that the exponential increase cannot continue. For one thing, there simply won't be enough people. There are limits to the number of people that can inhabit the planet, and so limits to the number of scientists. So when we consider the prospects for our own society, it seems plausible that the present era of very rapid expansion might slow down. We may well reorganize society to be, sustainable and low energy rather than based on continuous growth and expansion. Even if that's not forced by the nature of scientific development, various environmentalists and political activists are already pushing for a lower energy society on the grounds of planetary protection. If technological growth ends in our society for whatever reason, it seems very unlikely that interstellar travel would be developed, given that it's far beyond our present capacities. So it may be that most scientific civilizations show a pattern of a burst of rapid growth and high consumption, followed by settling into some sort of more sustainable lower energy state. And the important point here is that even if some technological civilizations develop the ability to traverse interstellar space, there's no good reason to expect that all or most of them will. Even if they exist for billions of years, it could be billions of years of a low energy society rather than one focused on growth. So the probability of S may well be low or at least unknown. That's one argument against a high value for the probability of S. Finally, another point we might make is that there's actually perhaps empirical evidence against a high probability of for S. Suppose we accept that interstellar travel is technologically possible and that other civilizations exist. This, of course, is a required assumption for any possibility of contact that could be harmful to us. Now, if we assume both that most civilizations will be far older than us and that there is a continuous exponential technological expansion, we run straight into the famous Fermi paradox. If these conditions hold, where are the aliens? They should have colonized the galaxy by now. At any rate, there should be clear evidence of their existence. Any view on the extraterrestrial question has to respect the basic observational fact that so far the skies appear to be empty. And so that seems to leave us with three options. Perhaps extraterrestrials don't exist, other scientific civilizations don't exist, but then at worst active SETI is a waste of time. It's not a significant threat. Perhaps interstellar travel just isn't possible. No matter how technologically advanced you get, the practical problems of interstellar travel can just never, even in principle, be overcome. Again, there would be no threat then. Or maybe even though interstellar travel is possible in principle, technology tends to reach limits, as the argument I've just outlined would suggest. But then the assumption that extraterrestrials will be substantially more advanced than us has to be abandoned. So they would be much less likely to pose a threat. Okay, so that's some of the bit of the arguments with respect to the risks of active SETI. That's all for today. Thanks for watching.